This lesson is on right triangle similarity. So we've been working with triangle similarity, but now we're going to look specifically with right triangles. So just to remind ourselves, right triangles have one interior angle measuring 90 degrees. That's this one right here. Now, it doesn't matter how you draw the triangle. If there's a right angle, it's a right triangle. The hypotenuse is the side opposite the right angle, the longest side. This is always the hypotenuse. The legs are adjacent to the right angle. So these two, the legs that form the right angle, those are called the legs of the triangle. And then the altitude is when we draw a line segment from the right angle to the hypotenuse. And this forms, it's a perpendicular line, so it forms a right angle. So it's from a vertex to the hypotenuse and to the opposite side, and that is an altitude. Now, in a triangle, any triangle, you can draw an altitude. And in a right triangle, it's the way that it's different is that you're from a right angle and you're forming a right angle. And the other two altitudes are actually the legs that are already altitudes because they're from the vertex to the opposite side and from this vertex to the opposite side, and that forms a right angle. So the altitude of a right triangle, there's actually three, but the one we're going to be talking about is the one that goes from the right angle to the hypotenuse. So just take a look. This is something you want to have in your notes. You want to make sure you understand what each of these are. And you should be able to draw this triangle in different ways and still be able to label all these things. So for example, if I had a triangle that looked like this, I could still draw an altitude right here. So this would be the altitude. This would be the hypotenuse. This is a leg. This is a leg. And we have the right angle. So it doesn't matter which way you move the triangle, you should be able to identify all of those parts. So pause and write that in your notes if you need to. So the first thing we're going to talk about is the right triangle altitude theorem. And basically what it says is if we do draw this hypotenuse, if we draw, the altitude from A, the right angle, to the hypotenuse, then we're going to form two triangles. And notice we've got the two triangles here. We've got triangle ABD and triangle ADC. And those two triangles are similar to the original triangle. So now we've got three triangles that are similar to each other. The important thing to know here is how we label these triangles. So if I start with triangle ABC and I want to write that it's similar, one thing we have to do is you have to do it in the same order. So angle A is the right angle. So that corresponds to angle D in this one. So if I'm going to write another similarity, let's change colors here. I'm going to write, it's going to be D. And if I go B, that's the longest leg. So I'm going to go D, B, and then back to A. That is the one that is similar to our triangle A, B, C. So you've got to pay attention. So this is the long leg and the hypotenuse. So I have to go long leg, hypotenuse. The same thing applies for if we have this third triangle. So notice when we do ABC, this is we start with the right angle, then we go the long leg. So we start with the right angle, we go along the long leg, and then the hypotenuse. So this would be triangle DAC. Because corresponding parts of similar triangles are proportional and angles are congruent. So we have to put them in the right order. So that's important to do. So let's take a look at this example. Which similarity statement is true? And notice they all start with SRQ. So if we're looking at triangle SRQ, we're going SRQ. Now in this case, the right angle is the middle angle. So what I want to say is, which one of these are true? Well, angle T in both of the smaller triangles is going to be my right angle. So I can say, well, this one or this one is going to have the T as the right angle because R is the right angle in this case. Now the other thing I like to do sometimes is I like to say, well, I'm going to redraw this and I'm going to make them look similar. So if this is angle T, which one is the long leg of angle T? Well, S is the longer leg and then R. And the smaller one, if I have angle T, which one's the longer leg? Well, R becomes the longer leg and TQ becomes the shorter leg. So I've kind of rotated them and reflected them a little bit. We talked about that in our last lesson, just so I can visually see and make sure I understand what they're equivalent to. So SRQ is the same thing as STR or RTQ. So which one of those? Well, this says RTS. Well, that's not true. So RTQ and SRQ are our similar triangles. So pause the video and try this one. Check all the statements that are true. So you've got 3 similar triangles. Let's see which ones of these statements are true. All right, I drew out these triangles. And remember, the right angle of the large one is K, but the right angle of the 2 smaller ones is M. And from there, then I thought, well, what's my shorter leg? In the smaller one, it's MJ, and MK is the longer leg. And in the larger of the 2, of the one that's split, MK is the shorter leg, and ML is the longer leg. And then I have JK is the shorter leg, and KL. Sometimes it helps if we write them like this. So the JKL, and I just go JKL, is that congruent? And then I say KML, they're in the same order. So that one's true. JKM says JKM. That means I go along the hypotenuse, JKM. And this says JKL. Well, JKL goes along the short leg first, so that's not true. Then JKM and KML. Again, that goes the hypotenuse and then the leg, and this goes the shorter leg. But then if we look at JMK, JKL, and KML, those are all in the same order, so those are similar. So now we're going to look at another thing, the geometric mean. If we talked about the arithmetic mean, that's when we add numbers and take the average. The geometric mean is when we do, like we use multiplication. So if we have 2 numbers, A and B, the geometric mean are the 2 numbers that if we cross multiply, they're equal. So A over X equals X over B, so we would have AB equals X squared. That's the geometric mean, and we're going to use that in a couple of different ways. The first one is there is a geometric mean altitude theorem. And it says if we have a right triangle and we have a hypotenuse, or altitude is drawn from the right angle to the hypotenuse, then these 2 segments of we split the hypotenuse into 2 segments, X and Y. And we have a geometric mean that says X over the altitude is equal to the altitude over Y, meaning the one segment over the altitude is equal to the altitude over the second segment. And you could write it the other way as well. You could write Y over H is equal to H over X, because you'll notice the cross products are going to be the same. So let's take a look at this. Which proportion does that equal? So where's our altitude? First we have to determine our altitude. Well, here's our altitude, right here is H. So we know H is going to be the bottom and the top. And now we need to find one segment over the altitude is equal to the altitude over the second segment. Well, here is my hypotenuse, this whole thing, and we've got 2 segments, 3 and 2. So we can say 2 over the altitude is equal to the altitude over 3, or we could say 3 over the altitude is equal to altitude over 2. And so we look over here, which one? And it's this bottom one right here. That gives us 2 over the altitude at H is equal to H over the altitude of 3. So now let's use what we know and apply it. So if we know that the geometric mean, altitude mean, the altitude is 9, so we can set up a proportion. 5 over 9 equals 9 over 2x plus 3. And then we just cross multiply. So we do 5 times 2x plus 3 is equal to 9 times 9. And that's where we get 10x plus 15 equals 9 times 9. So we get 10x plus 15 equals 81. Subtract 15 from both sides, so we have 10x equals 66. Divide by 10, so we have x equals 6.6. So x is 6.6, but the length of DE, then we substitute that in. We say 2 times 6.6 plus 3, and that's 13.2 plus 3 equals 16.2. So the length of this section right here is 16.2 because we have to substitute our x value in. So pause the video and try this one out. All right, check your work. You should have set up the proportion as 4 over a equals 8 over 18 and simplified that to 6 radical 2. Here's one more. Try this one. Again, we just set up our proportion 8 over m equals m over 20 and solve, and it's 4 radical 10. Our next theorem is the geometric mean, but with the leg theorem. And what this says is if the same thing, if we draw an altitude, we're going to cut this hypotenuse into 2 segments, x and y. But this time we're going to take the whole hypotenuse, which is x plus y, and we're going to put it over the value of the leg. So x plus y over the leg is equal to the value of that leg over just the segment of the hypotenuse that it is part of that smaller triangle. So in the same case, we would do, if we were looking at B, we'd take x plus y, the whole thing, over the leg. So if we're looking at B here, we do x plus y over b, and that is equal to b over the leg that is associated with that smaller triangle. So let's see how that works. What is the value of q? So if we have q, that's a leg we're trying to find. So we need to set up a proportion. So we take our whole hypotenuse, 10 plus 4 is equal to 14, and we put it over the leg, and then we take that leg, and now we have to just take the segment that is associated with that leg in our new right triangle. So that's over 4. Then we just cross multiply, and we get q squared equals 56. Take the square root of 56, so we get q equals, and then 56 is equal to 4 times 14. So that's 4 times 14. And then we can simplify that as 2 radical 14. So that would be our value of q. So take a look at this one and try this one on your own. So if we look at this, we set up our proportion 20 over a, the whole hypotenuse over the leg A is equal to the leg A over the section of that hypotenuse, which is 14. And if we get this, we get 2 radical 70. And I tried to get 70 to go down further, but 2, 5, and 7 are all prime numbers. It does not factor any further. So that's our final. Pythagorean theorem. This is probably one you're familiar with. So let's just review it quickly. It means in a right triangle, whichever right triangle we have, a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. And so when we split up a triangle, then we have a new leg, and a hypotenuse. So just be aware when you've got these similar triangles that come into play, make sure you're using the right values. So if we were going to prove this is just kind of walking it through. It's saying you can use this proof, and this just kind of walks through. If you want to walk through this, pause the video and take a look at this. Make sure you understand. But this is how you can prove the right triangle, a squared plus b squared equals c squared, using this similar triangles formed by an altitude ratios. So let's find what is the value of s. Well, the first thing we have to notice is we've got, whenever they're asking you for a missing value, say, what do I know and what can I use? So in this case, I've got 8 and I've got 15 and I'm trying to find s. Well, that I have a right triangle. So I can say 8 squared plus 15 squared equals s squared. And if we simplify that, we get 64 plus 225 is equal to s squared. So 64 plus 225 is equal to 289. Take the square root of both sides and we find out s equals 17 units. Now we're just going to go through some of the problems from your assignment, and let's make sure we understand what we need to use. So in order to find the value of k, we have to look at what we know. We don't know L, so we can't use the Pythagorean theorem. We do know the altitude is 4. So in this case, I say, oh, I can set up k over 4 is equal to 4 over 8, because that is my geometric mean altitude theorem. So then I cross multiply 8k equals 16, so k equals 2. In this case, the sides of the equilateral triangle are each 8 units. Notice they're all marked as 8. They're all congruent, so they're 8. So what is the length of the altitude? Now, if we draw an altitude, and if it's an equilateral triangle, that we know that these segments are also congruent. So what's half of 8? Well, this section then has to be 4, and we're trying to find this altitude here. So now we can say, well, I have a right triangle, and I know 2 of the sides, so I can set up my Pythagorean theorem as a squared plus 4 squared equals 8 squared. So a squared plus 16 equals 64, a squared equals 48. Take the square root of both sides, so a equals, and I'm going to say the square root of 48, which is equal to the square root of 16 times 3. So a is equal to 4 radical 3. So that one we use the Pythagorean theorem. Pause the video and see if you can solve this problem, and make sure you know what you're being asked for. This is using the geometric mean leg theorem. Make sure once you find x that you substitute it back in to find the correct side. All right, try one more problem and come back and check. All right, pause the video and take a look at the steps to get your correct answer.